let's start with the question. I will definitely make it. So you are given n towers numbered from 1 to n. Tower I has height of h of I. At time 0 you are on the tower with index k and the current water level is 1. Every second water level rises by 1 unit. At any moment, if water level becomes strictly greater than the height of the tower you perish. You have a magical ability. At moment x, you can start teleporting from tower I to tower j, which will take h of I minus h of j seconds. That is until moment x plus h of I minus h of j. You will be on tower I, and at the moment x plus h of I minus h of j, you will move to tower j. You can start a new teleportation at the same moment. You just arrived at tower j. Okay, so basically in this question we have towers from 1 to n. Okay, and we have an array that contains heights at the particular tower, that is h of I. Okay, so h of I gives us tower height. Okay, height of tower. Okay, so and at time 0 you are on the tower with index k. So at time t is equals to 0, you are on the kth tower. So tower number k is from where you are going to start. Okay, and the current water level is 1, so the water level starts from 1. Okay, so and every second the water level rises by 1 unit, and at any moment if water level becomes strictly greater than the height of the tower you are on, you perish. So we have to choose a tower such that you stay above the water level, and the water level is going to rise by hi minus hj. Okay, so the difference between the heights of the tower, and you have to reach the maximum tower in the end. Okay, so how are we going to approach this problem? Let's see. So for that, let's see the first test case, and we have n and k as 5 and 3, and we have the heights as 3, 2, 1, 4 and 5. Okay, so it's the 0th tower, first, second, third, fourth. Here the tower number is according to the 1 waste indexing, but we are going to do with 0 waste. Okay, so the third tower is from where we are going to start, so which means the second index. So we are going to start from here. Now we are going to have water level as 1 from the starting. So at water level is equals to 1, you are at this tower, right? So now which is the next tower that you are going to choose? Okay, so let's choose this tower. If we choose 5 only, because we have to reach at the maximum height, right? And how, if we are going to reach the maximum height or not, we have to tell that. Okay, so as we can see that if we have to jump from tower number 3 to tower number 5, what is the cost of that? So the cost would be 5 minus 1. So height of the tower at index 4 and height of the tower at index 2. Absolute difference of this. Okay, and we get 4 here. Now when we add 4 to the current water level, it becomes 5. Now we have to check if the water level that is going to rise, is it more than the current tower or not. If this water level is enough to jump or not. Okay, because at the end we have to reach here only. Okay, so in order to understand this condition, let's see the example given in the question. So in this example, when n is equal to k is equals to 4, so the tower is the 4th tower and we have to jump to this tower, okay, with the maximum value of 4. Okay, so the cost would be 4 minus 2 plus 1. 1 is the initial water level. Okay, so it becomes 3, right? So now we can see that we can do this transition. Okay, so we were able to do this transition from 2 to 4. Okay, so the height of the current tower is 2, while the total cost is 3, and we were able to make this transition, right? And if we see that at when the water level was 0, it was here, the water level is 1 here, right? Then the water level increased to 2, and as soon as the water level increased to 3, the ball was teleported. Okay, so the player or the ball, whatever it is teleported, right? So that means that the cost should be greater than the value of the current tower plus 1. Okay, so this should be the condition in order to make the transition, right? So now let's get back to our test case. So we have here 5. Now 5 must be less than or equal to 1 plus 1, the height of the current tower plus 1. Okay, so as this condition is failing, so it will not be able to jump here, right? Now let's see if it is going to jump here. So the cost becomes 1 plus 4 minus 1, that is 4, and 4 is also greater than 1 plus 1, right? So this condition is also false. This the condition where it must be greater than the cost, it also is not satisfying. Okay, now let's see if it can jump from tower 1 to tower 3 to tower number 2. Okay, so if we want to make this transition, we are going to have the cost as the initial water level was 1 plus 2 minus 1. Now we have to check if the cost is greater than or equal to the current element, current tower height plus 1, right? And it is 1 plus 1, and the cost we have here is 2, right? And 2 is greater than equal to 1 plus 1, that is 2. So this condition becomes true, right? So we can make the transition from tower with height 1 to tower with height 2, right? What would be the next transition? The next transition would be to tower with height 3. The cost, if we calculate the cost, it will come out to be the previous cost, which was 2 plus 3 minus 2, which is equals to 3, which is equal to this element, hence the transition can be made. And similarly, the transition is going to be made from 3 to 4, and if we calculate the cost here, the cost would come out to be previous water level plus 4 minus 3, which we get as 4, and it's equal to this, hence the jump can be made, and similarly to this. Okay, now if we observe what have we done in this question is that 1 jumped to 2, 2 jumped to 3, and 3 jumped to 4, and at the end 4 jumped to 5, right? So these were the optimal jumps that were made, right? So we can see that we can sort the heights of the towers. Okay, so if we sort the heights of the tower 1 2 3 4 and 5, so the minimum jump that one can take from this tower, because this was the starting point, right? So we have to jump, we can jump from this to here, and the cost was satisfying, hence we can also jump from here to here, then we can make the jump from here to here, and at the end here to here. Okay, so one thing we have to keep in mind is the jumps are made to next greater element, right? So this is the first observation that we made here. Okay, now so the answer for this possible test case would be yes, right? Now let's see the second test case. Okay, and we have a 1 3 and 4. If we sort it, we only get 1 3 and 4. The value of n and k here is 3 and 1. So now let's see if the jump from this tower, first tower, to this tower can be made or not. Okay, because as the tower number 1 had the height of 1, right? So after sorting also we can see that its position is 1. Now we can see if the jump can be made or not. Okay, so let's calculate the water level. So the initial water level would be 1, right? And we are going to add here the jump, which is going to be 3 minus 1, and which gives us the answer as 3, right? But 3 is not less than or equal to the current height, which is 1 plus 1, right? So this condition is not satisfied, as the minimum possible jump is not possible in this array. That means that if one tries to jump from here to here also, it won't be possible. So as soon as this is not possible, we are going to stop and the answer would be no. Right, let's see another test case to understand this better. So next test case is n is 4, and k is also 4, and we have the array 4 4 4 4 4 and 2. Okay, so we are going to sort it 2 4 4 4, right? And let's see if this transition can be made. So the current water level is going to be 1, and the transition is going to be 4 minus 2. We have 3. So 3 must be less than equal to the height of the current element, which is 2 plus 1, and this condition satisfied, so the jump is going to be made from here to here. And as we can see, 4 is the maximum element, so we can stop here, right? And we can output yes, because the jump was made from the given tower to the maximum element, right? So let's see one more test case. Okay, so we have here n and k as 6 and 2, 2 3 6 and 9 1 2 9 1 2. Okay, so when we sort it, we get 1 2 3 1 double 2 3 and 6 and 9. Okay, so the starting tower was tower number 2, right? And 1 2, this is the tower number 2. Now we are going to search for the tower with height 3, as the tower number 2 had height 3, so we are going to search the position, right? And we get this position, right? And we are going to start from here. Now we can see if the jump is made, so the current water level is 1 plus 6 minus 3, the cost of jump, right? And we get here 4, right? And if we see the current element, it's 3, and we are going to check if 3 plus 1 is greater than or equal to 4 or not, and it is, hence the jump is going to be made from this position to this position, right? Now similarly, the jump can be made from this position to this position, and we'll check. So the water level was 4, right? And the cost of jump was 9 minus 6. Now we have 7 here, and we are going to check if the height of the current element plus 1 is greater than or equal to the cost or not, the water level or not. So it is, and the jump has been made. And since we have, right, so not in this array, it's going to be in this array, right? So since the jump has been made from 6 to 9, and 9 is the greatest element, we are going to stop and output yes, because it is possible to reach, right? Yes. Okay, so now let's see the code for this question. So we have n and k, we enter the values of n and k here. Now we declare the vector heights, right? And we have here t is equals to 0, max element is equals to 0. T is the variable that I've took, in which I'm going to store the height of the element we have to start with. Okay, so the starting height is going to be stored at t. Okay, now we have max element, which is going to store the maximum tower height. Okay, so now let's see, we run the loop and we enter the value of heights, and as soon as the value of I becomes equal to k minus 1. So k was the tower number and we have 0 based indexing, so we are going to subtract 1 from it and we are going to store the value, right? And we are also going to calculate max element side by side. Okay, so I have made bool f is equals to true here. Okay, so here we are sorting the heights, right? So in the approach we were sorting the height, right? And the starting index we get from binary searching. So we have here the water level as 1. We start with the water level 1, right? And for I is equals to start index, the start index which we have searched with the help of binary search. So this binary search tells us the maximum possible location of that height. For example, if we have height is equals to 2 and we have the sorted array as 1 2 2 2 and 4, okay, so it's going to give this position. Okay, not the first position, it's going to give this position. Okay, so we are going to get the index from here, right? Now if the height of the element is equal to maximum element, we are going to break because we have found the element and there is no need to traverse further, right? So if f is true, we are going to output yes, else no. So here f is going to be true because it was true, right? And else we are taking a temp variable which calculates the possible water level if the jump is being made. Okay, so if that is less than height of the current element plus 1, we jump to that position, right? And the water level changes to that. Okay, and we go to the next possible height. But if it is not true, then we are going to write, because the element is going to have the jump to the nearest possible minimum element, right? Because as we can see in this array, the 2 is going to make a jump towards 4, right? And if that condition is not satisfied, it cannot make the jump, then it's no point to go any further, right? So we are going to break out of the loop, right? And if f is false, then we are going to output no. So this was the code for this question, and I hope you understood the solution to this problem and the approach we are using in order to solve it. So if you have any doubts, you can leave in the comment section. Thank you.